All right, welcome back. So we're going to look at another one. This, by the way, I didn't mention it. This is called like the p-test. Okay, it's p-test for integrals of this form. Okay, but we're going to have another p-test. I did not pick the name. Okay, but we're going to have another one, and we're going to take the integral from 0 to 1 of 1 over x to the p dx. Okay, now this one has a problem actually at x equals 0. Okay, so this one, right, because at x equals 0, we have this situation where we have a discontinuity. Okay, now again, let's look at first what happens when p equals 1, because that's a special case. Okay, so again, now what we're going to do, we're going to take the limit as t goes to 0. We could put a plus there from the right. We don't really need it because it'll be sort of understood by writing the integral t to 1. Okay, but it doesn't hurt to put it there. Okay, again, the antiderivative, since p equals 1, we're just going to use 1 over x. So that's going to be the natural log of x from t to 1. Oops, let me put the limit on there. Okay, so that is the limit. T goes from 0 to the right, and we're going to have natural log of 1 minus natural log of t. Now, natural log of t, as t goes to 0 from the right, that's going to go to negative infinity. So this is going to be infinity. And again, we say this is divergent. This is a divergent integral. Okay. All right, let's take a look now at what happens when p is not equal to 1. Okay, so we're going to take again the limit. T goes to 0 from the right. T1, 1 over x to the p dx. Okay, so now again, p is not equal to 1, so we can take the antiderivative without the natural log. So that's going to be, again, negative p, so it's going to be x to the 1 minus p over 1 minus p. T to 1, again, I forgot the limit. You can see how easy it is to forget to write it. Okay, so then that equals, again, now limit t goes to infinity. Let me move that up here. And we're going to get 1 over 1 minus p, that's at 1, minus t to the 1 minus p over 1 minus p. Okay, let me write that out a little bit differently. We're going to factor out the 1 over 1 minus p. 1 minus t over t to the p. Okay, so now let's go ahead and just think. Remember, we've got the p bigger than 1, p less than 1 dichotomy. Okay, so if p is bigger than 1, Okay, now remember, t is going to 0. Okay, so as you go to 0, if you think about this, think about like taking small numbers and say squaring them. Okay, if you square 1/2, what do you get? 1/4. If you cube 1/2, what do you get? 1/8. So when you take small numbers and you raise them to a power, you're getting smaller numbers. Okay, so that means if p is bigger than 1, t to the p is actually smaller than t. Okay, so that means this is going to infinity. Oh, other way around. Okay, because it's going to 0. Okay. If p is less than 1, okay, then we have the other way around. Okay, so that means that this integral equals, well, it diverges now if p is bigger than 1. Okay, and it converges to 1/1 minus p if p is less than 1. Okay? All right, so those are the two p tests. I'll be back with more in the next video.